All right, so we are now looking at a Trane CGAF air-cooled chiller, and we've gone over air-cooled a little bit. As you can see, air-cooled part means we have condensers to transfer the heat outside, but we are still water-cooled. Here's our chill water loops from the building. Our pumps are in the mechanical room. So let's go over a PM. So the first thing you want to do before you do anything to any chiller when you walk up is check the panel. You want to make sure there are no alarms, because if you go ahead and you throw the disconnect or you turn the power off, you're going to lose you could lose your alarms. You might even lose the history and not be able to see it. Older panels don't date stamp alarms as well. Like, this is an older panel. So that's the first thing we want to check. This is a UCP2 panel from Trane. They still use it today. Obviously, software is more up to date and stuff like that. Also, on a lot of the panels, once you get in here, you can find the passwords, which are right, usually somewhere. You find them somewhere located. Also, you're going to find the schematics hanging up. These are all stuck to the door. This is a little bit unusual. Usually we can pull the schematics off and read them. They normally don't come stuck to the door. You'll also have another data stamp plate here on the inside. That's normal. You usually find that because the sticker, which is still legible, can get a little old and faded where we can't read it. Okay, the second thing you want to do is you want to find the main disconnect for the chiller before you touch it. You always need to know where it's at. This one's on the wall. There's obviously something in my path to get to that. That's a little bit aggravating. In fact, all this stuff, and this is kind of normal, you'll see this, all this stuff pretty much up against my chiller is kind of aggravating, but those are things we've got to deal with customers. If it gets too bad or it's a safety issue, I would let them know, and they would have to fix that pretty instantly. So now we need to check our power. So you get your meter, throw it somewhere, stick it somewhere where you can read it and not get tangled up. I'm going to stick it over there. So we'll cover the electrical part of the PM. For me, the first thing I do is I'm going to check the incoming legs of power. This is a campus that I know runs on 208, which is not common. 208 is not common. It's usually 460. So let's go ahead, and first thing we're going to do is we're going to go 1 to 2, and we got 210. Then we're going to go 2 to 3, 210. And then we're going to go 1 to 3, 211. So our incoming power is clean, and we know all the legs are correct. Now, if you can actually follow the wires to the top of the circuit breaker, and you have the same legs over here. You have L1, L2, right there, C211. Down here on the bottom, kind of hard to see, but what we're going to do is we're going to go from here to here and check the drop through the circuit breaker. I don't know if you could see that, but I'm looking for 0, and that's 3 millivolts, which is technically 0. So I'm having the sun is killing me, man. Okay. And the next thing we want to do is we want to check our fuses, and our fuses are right here. And what I do is I go from the top to the bottom, and I'm looking for 0. I got 0, 0, I got 0. I'm in millivolts. Millivolts is 0. When I'm showing millivolts, 5.2 millivolts AC, that's 0. 8 millivolts, that's 0. What I'm looking for is 1 volt or higher. If I get 1 volt or higher drop through this fuse, it's gonna go. And now what I'll do is I'll go from ground to the fuse to make sure the fuse actually has power, and it's 120, 120, 120, 120, 120, 120. Now you can come over here and go to ohms or continuity. A lot of guys will do continuity, and they'll come hit the fuses, get their beat, move on, beat, move on, move on, move on, move on, move on. I don't use the beeps usually. I stay on the volts, because remember, like I told you before, these two leads on this meter, they're reading the difference between each lead. That's all the meter does, is reads the difference between this lead and this lead, right? So if I come to the top and bottom and I've got 0, there's no difference. If I've got 120 volts right here, that means the difference between the top of this fuse and the bottom of this fuse is 120 volts, which means this fuse is bad. So know how your meter works, and so you could use your meter properly. Now what I'm going to do is come over here. I'm going to check my big transformer. I'm looking for line side power, which is 210 volts, and I got it. Now I'm going to come down to the bottom and check my outgoing power, and I believe this transformer is stepping down to 120, and it is 125. And if we need to know that and we're not sure, we have our ladder diagram over here, and we could figure that out pretty quickly. These are the condenser fan contacts up here. I've already have them labeled because this is my contract, and Brady and the guys at work, we all pretty much label everything. Like I got this terminal block labeled 1TB9 and so forth and so on. So I got 1K7, 1K8, and if I need to know, if I need to figure that out and I don't know, I just get the wire number here, right? And I could come over here to the legend, and I could find my condenser fan contacts, which are right here. I already found them, and I said this was 1K7, so I'm gonna look for 1K7. Condenser fan contactor 1K7 is the device designator, condenser fan contactor, and now it gives me the line numbers on the ladder where this is located. So this is 130, 132, and line 165. So really all I need to do is find line 130, 132, which is right here. I think, let's make sure this, you guys are almost seeing what I'm seeing. Let me see here. Yeah, this is too small. We're not going to be able to read this on my camera, but your line numbers run down the left side of a ladder. Okay, so I find 130, and then I just follow to 130 until I find a 1K7, and then I find my 1K7. I get my, it gives me a wire number, and I can then find the wire number on the bottom of the contactor. I know that's 1K7. I don't want to look that up no more, so I write it down: 1K7, 1K8, 1K9. The biggest thing with air-cooled chillers is condenser fan motors going out. So we definitely want to check these. Now on these, with these contactors here, when I've only got one motor, one fan motor per contactor, as we could see here, I could come here to the top of the contactor. There's no power because the unit's off, or I mean the unit's not running. There's power to the system. I can ohm that out there. So 1 to 3 is 3.3 ohms. Now I'm gonna go 2 to 3, and I'm looking for, and I've got it, 3.3 ohms again. And now I just do 1 to 2. I'm looking for 3.3 ohms again, and I got it. Okay, that's all you're looking for. You ohm these motors out. You could go to ground as well, but if it's to ground, your ohms through the legs are going to be different. And I don't care what the motor is. All I know is I want to see all 3 legs read the same ohms. Now, if there's anything else on this circuit besides these wires going straight to a fan, you'd have to disconnect stuff to get a clean reading. But these are one fan per contactor. The contactor is not pulled in, so I've got nothing interfering with my ohm reading. See, that's 5.1, that's 5.1, and that's 5.1. That's the same fan motor as these two. These two read 3 ohms. This one's reading 5 ohms, but all 3 legs read the same, so there's nothing wrong with that fan motor. I'm not even going to bother with it. And we're going to continue down the line. Now I'm back down to 3.2, 3.3, 3.3. Nothing wrong with that motor. 3.3, 3.3, 3.3. Okay, all of them read 3.3. This one read 5. Resistance is getting a little high. So if I were to venture a guess, that's probably the next motor getting old, running on its way out. Maybe, possibly, maybe not, but all 3 legs read the same. That's all I care about. Now I have overload circuit breakers for our compressors, and we come out of the service L1, L2, L3 into the top of the breakers. So out of the service into the top of the breakers, L1, L2, L3. We come out of the breakers and we come down here to the compressor contactors, which I have labeled 1K3, 5, 4, and 6. Okay. And I'm still on ohms. I'm going to slide my meter down here. And if you don't have a decent meter, get a decent meter. I use Fluke exclusively. My life depends on these meters being accurate and not breaking. Nothing wrong with field piece, but my life's on the line. I use the best tools I can get. And go ahead and get the magnet strap like I've got right here. This makes your life so much easier. You just, all I do is hang my meter right there. It's out of the way. The leads are in my hand. I'm not getting tangled. I can read the display. Blah, 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 blah. Down here, so I know I've got my 211, 210. I'm right in line with the way I measured my service. Now, I know how this chiller is wired. And the bottom of these leads here, all these leads here go straight to the compressors. Just like I explained up there, those those wire leads go straight to the motors, straight to the windings. I know how the chiller's wired. There's nothing in between this lug right here for this L2 and the compressor lug. There's nothing. Okay, where we left off was I was ohming out the compressors down there on the bottom, and they all ohmed good. So now we're going to keep moving. I want everybody to keep in mind that this unit here, this is about an 02, 03 unit, maybe even a little bit older. So this is an outdated design, but it's still a chiller. It's still out there, or it's still an air-cooled chiller. You're still going to see them. Okay, so the basic PM's electrical side still kind of complies. You got contactors, fuses, breakers in the most advanced chillers, so it doesn't matter. Okay, remember I told everybody earlier, here is your condenser fan contactors. Okay, now I want to hear the fans run. I want to know they're working. There are a couple of different ways we could go about getting that done. I could fumble through the UCP2 control system and energize contactors one at a time. I don't have a box to get on the terminals and activate the actual pull in the coil and the contactor. So I'm not going to be able to do that either. What I can do, and what I did do, was I activated the contactors one at a time. I listened to them run, I listened to them wind down, and the 1K10 fan motor, which is the one all the way in the back on this side, is running rough. That's probably going to go out soon, and I'll let the customer know. So we're trying to control this unit doesn't have VFDs, so we're trying to control the condenser pressure by using pressure switches. And what that allows us to do is we set the opening and closing of the switch, and you could follow the red wire on the coil. You can follow that red wire down to the terminal block, and then it comes over to the pressure switch, and then it goes to the board where it's activated. So all we're doing is we're breaking the circuit that pulls the coil in, and we get to decide what pressure we're breaking that at. All that's really left to do on this chiller, and it'll take some time, is I'll have to wash the coils here with cleaner. And just one thing I want everybody to keep in mind: before you go up to a chiller and start spraying it with cleaner and corrosives, check your pipes, check around the chiller for oil, because oil is going to indicate a leak. And if you wash the coils, the cleaner and everything is going to wash away the oil, and you could be washing away the only evidence that you have a leak. And the next time you'll know you did have a leak is when the chiller goes out on low pressure or something silly. So before you go ahead and start cleaning everything up and spraying everything in here, go ahead and you want to check all around the chiller, all around the pipes. You want to put your hands on them, and you want to look for oil. This is a good time to get your soap bubbles out and start spraying connectors. Definitely spray all around where anything that's screwed into the system. You want to spray that with bubbles. Any caps you find on the system, you want to spray that with bubbles. Definitely spray these oil distribution lines. Just spray everything, looking for leaks while you're doing it. closely, you'll see there's a little tab here that says 47. Okay, so you could come down here to where find the 47 on the notes and read, and it says this 1K13 and associated wiring used only on 50 and 60 ton units. So if you don't have a 50 or 60 ton unit, this section of the ladder, this boxed out part right here, this doesn't apply to you. So you need to know what you're working on. You need to keep in mind when you're reading your schematic, even if you land on the chiller you know you're supposed to be on, and you see that note, you better go down, you better check the notes and make sure that that applies to you. So you need to keep all that in mind.